Hello everyone. So welcome back to my channel. So we have already learned Taylor series method, so which comes under initial value problem, and today we'll learn Euler's method, which is another initial value problem. Now this method is also called Runge Kutta method of order 1. So let us first consider a differential equation dy by dx equals to f of x comma y. So I think you still remember that in Taylor's method also we have taken one differential equation which is of the same type. Okay, dy by dx is equals to f of x comma y. So this is a first order differential equation, and with some initial condition x equals to x naught and y equals to y naught. So means if y equals to f of x is the function, and if we put x naught in place of x, if we put x naught in place of x, then y will become what? Y naught. So this is the initial condition which is given to us, and we have to solve this particular differential equation. Okay, so let us take differential equation as equation number 1. So we have to solve this equation under this initial condition. So for that, what to do? We have to consider the differential equation which is given and the initial condition which is y naught. This is the initial condition. Now before solving, let us take some equidistance values. So what is equidistance values? So if y equals to f of x be a function, be a function, then x naught, then x1 is also known as x naught plus h. Okay, then x2 is our, you can write x naught plus twice h, or you can directly write x1 plus h, anything. So x2, then comes x2, our x2 is, now x2 we have already written, x3 equals to, either you can write x naught plus thrice h, or you can write x2 plus h. So we have taken some equidistant values or equispace values. Equispace values means, you see, if you observe x naught, okay, if you observe x naught, then this is our initial value, and in the next value we have increased it by h, x naught plus h. So there is a increment of h, and in the next term it is x naught plus twice h. So again, what is the increment? H. So they are equally increasing with a value h. This h is also called step size. Okay, each step. Okay, since sometimes you see, if you see the staircase, and if the height of the staircase is all same, no height, suppose it is 8 inch or 10, 8 yes, 8 centimeter or 10 centimeter. So if it is equal, then you can say that it is equal step size. So here also x naught, our second term is x naught plus h, then x naught plus twice h, then x naught plus thrice h. Like this, we are taking some what equal values of x, and if we put these values in y equals to f of x, in y equals to f of x, the corresponding values of y will be what? Corresponding values of y are y naught. So for x naught we are getting y naught, then for x1 we will get y1, for x2 we will get y2, then y3, and dot 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 dot. But remember, these values may or may not be equal. I'm talking about y naught, y1, y3, and y2. These values may not be equal because we are taking the values of x are equal, but when we put the values of x in y equals to f of x, so whatever value of y comes, so that values may or may not be equal. So in general, the values are not equal. if you take a function y equals to x square, okay, suppose y equals to x square. So when you put 1, x equal to 1, our y will be 1. Whenever we put x equal to 2, our y will become 1, 4. Okay. So let us search that. If we put x equal to 2, y will become 4. If we put x equal to 3, it becomes what? 9. Now see, you see, the values of x are increasing equally 1, 2, 3. Step size is 1. But the values of y are 1, then 4, then what? 9. So they are not equal. So that's what I'm saying, that the values of y may or may not be equal. Okay. So what we have got till now, some equal values of x and the corresponding values of y. Now let us take equation number 1 and try to solve them. Now, equation 1, we can write like this, right? dy is equals to f of x comma y, and then what? dx. Okay. So equation 1, we are separating. Dy we keep in the left hand side, and dx we have taken on the right hand side. Now if we integrate this particular y between the limit y0 to y1, y0 to y1 means we are taking the first two values of y0 to y1 dy, then what will be our right hand side? Our right hand side will be, see, at y0 the values of x is x0, and at y1 the values of x is x1. And now this function f of x comma y, at the initial point it will become f of x0 y0, and then what? dx, right? So at the point x0 y0, this particular function f of x comma y will become f of x0 and y0. Let us integrate it. It's a very simple integration. We all know that what is integration dy? Integration dy is y between the limit y0 to y1. And on the right hand side, f of x0 comma y0 is a constant term. So let us take it outside. And then we are left out with integration dx. Integration dx is x between the limit x0 to x1. Now let us put the limit, it's upper limit minus lower limit, then f of x0 comma y0, and then x1 minus x1. Now if you look at this particular relation, then you see y0, y0, this f of x0, y0, x1, x0, these values are known to us. Only the value y1 we don't know. So let us find y1 from here. So y1 equals to y0 plus f of x0 comma y0 into x1 minus x0. So by using this particular relation, we can find the value of y1. Okay. So this is also called first recurrence formula. So similarly, in the same way, if we proceed, then we can find y2, y3, y4 up to n term we can find. Okay. How many values we have? How many values of x we will take? So depending on that, we will get the values of what? Y. So let us find till n term. So proceeding in the same way, similarly, what is y2? Just observe. In the above equation, in left hand side we have y1, and on the right hand side the first term is y0. Now we are writing y2, so the first term will be y1, then f of x1 comma y1, and then it will be your x2 minus x1. Okay. Similarly, we are writing then y3. Y3 will be what? Now it is y2, f of x2 comma y2, and then x3 minus x2. Okay. So in the same way, if we proceed, so let us write f for n plus 1 term. So it will be yn, f of xn comma yn, it will be xn plus 1 minus xn. Okay. So like this. Now the thing is that how many terms we have to write, that I'll discuss in the problem. It is purely based on step size. how many step size we are taking. So on the value, and at what point we have to find the value of y. So depending on step size and at what point of x we have to find the value of y, depending on that we have to take the number of values of y. So that we'll discuss in one problem. Okay, so is it clear? So initially we have taken a first order and first degree differential equation with initial condition x equal to x naught and y equal to y naught. Then after that we have taken some equidistant values of x like x naught, then x naught plus h, which we have written as x1, then x naught plus twice h, x naught plus thrice h. So like that we have taken some equidistant values of x, and if we put these values in the function y equals to f of x, then we get some corresponding values of y, which are y naught, y1, y2, y3, dot dot dot. And then if we integrate between the limit x naught to x1 and y naught to y1, we'll get the first relation. Okay, first relation, which is y1 equals to y naught plus f of x naught comma y naught into x minus x naught. So if you integrate between y1 and y2, whatever answer we are writing here now, similarly this you will get. If you integrate equation number 1 between the limit y1 and y2, this will come. Similarly, if we integrate this one between the limit y2 and y3, this will come. Okay, now let us do one example. So problems are very easy. Let us take the first problem. Given dy by dx equals to y minus x divided by, let us take y plus x with initial condition, with initial condition y equals to y1 at x equal to 0. So means what? X not equal to 0 and y not equals to 1. Now what to find? Find y at x equal to 0.1. Okay, so at this particular point we have to find the value of y. So it will be mentioned in the question that solve this initial value problem by Euler's method. Otherwise you can use Taylor's method also. So it is up to us. Okay, now let us start. So here what is given? Dy by dx is equals to y minus x divided by y plus x, and x naught, our x naught is 0, y naught equals to what? 1, right? To find y at x equal to 0.1. Okay, we have to find y at x equal to 0.1. Now just now we did, or we have explained what is Euler's method and how to get the different formulas of y, so-called recurrence formula, how you get those recurrence formulas. So now on those, when we write y1 or x1, we see that h comes, so that h is called step size. So here what to take? Okay, we have to take some step size, and this is up to us what we will take. So what is the value of x? Is 0.1. Okay, 0.1. So if you take h equals to suppose 0.2, okay, h equals to 0.2, then how many steps we have to take to reach the point 0.1? So I'm doing it here. Our x is 0.1. So step size, it is up to us what we will take. If you take 0.2, then see up to fifth step we have to go. What is x1? x1 is our x naught plus h. So what is x naught? X naught is 0. So 0 plus h is how much? 0.02. Then x2. What is our x2? It is x naught plus twice h. So we'll get 0.04. Then x3 will be our x naught plus thrice h, so it is your 0.06. Then x4 is x naught plus 4h, which is 0.08. And then finally x5 is how much? X naught plus 5h. So now we'll get 0.1. Okay, so at what point do we have to find the value of y? 0.1. If you take a step size 0.02, then after fifth step we will get the point 0.1. So that means indirectly we know that we have to find y1, y2, y3, y4 and y5. Okay, y5 we have to find. Now this h, if you take 0.01, this value h, if we take 0.01, then up to 10 step we have to do, so it will be a little bit more calculation for you. And if you take suppose 0.25, h equal to 0.25, then 4 steps we have to do. So it is completely depending on us that what step size we want to take. So here in this particular problem I have taken h equals to 0.02. So for us we need 5 steps. Okay, now let us find one by one. So I think it's clear to all of you. Now by Euler's method we have y1. So our y1 is y naught plus f of x naught comma y naught into x1 minus x naught, right? So this is the formula we got. Now y naught. So y naught is given in the question. You see our y naught is 1. Then f of x naught comma y naught. So where from we find f of x naught comma y naught? What is the equation? Our equation is dy by dx equals to y minus x divided by y plus x. So this term, no, this right hand side term, this is our f of x comma y. Okay, this is f of x comma y. So what will be our f of x naught comma y naught? So our f of x naught comma y naught will be, this will be y naught minus x naught divided by y naught plus x naught into x1 minus x naught. Now see, all the values we know. Okay, each and every value we know. How? See, first is y naught. Na? The value of y naught we have already put here is y1. Then again we have y naught. Y naught is 1, x naught is 0, and this x1 we have here. So see, this is our x1, right? X1 is how much? Point. Just we have to put all the values here. Okay, calculate it carefully. So when you put all the values, our after calculation you will get 1.02. Is it all right? Y naught is given in the question is 1. X naught is also given in the question is 0. X1 after taking step size 0.02, we got our x1 is 0.02. So if you put the value of x1 here, so y1 is 1.0. Now we have to find fifth step, right? Since x5 is there, so let us find the others. Now y2. So in the same way, what is y2 then? It's y1 plus f of x1 comma y1 into x2 minus x1, right? So it is nothing but y1. Y1 just now we got, no, it's 1.02. Then f of x1 comma y1. So it's y1 minus x1 divided by y1 plus x1. From the function we are writing it. And then it is x2 minus x1. So again you see y1. Y1 is how much? Just now we got it's 1.02. X1 is how much? X1 you see is 0.4 by 0.04. And then x2 is 0.02. So if you put all these values, no, if you put all these values after calculation, how much we will get? our y2 will be, it will be your 1.0792. If you calculate it, you'll get exactly this one. Now find y3. So y3 is y2 plus, it will be your y2 minus x2 divided by y2 plus x2 into x3 minus x2. So in the same way, if we put all the values, everything is known to us. x3 is 0.06. So after putting the values, when you calculate, you will get 1.05771. So I suggest you to calculate it by your own. Okay, so when I am calculating, so I am getting this one. So maybe a slight error will be there when you calculate it, or you may get the exact same answer. So numerical analysis, so most of the cases, so answer vary person to person, it's dependent on calculation. y3, then it's y3 minus x3 divided by y3 plus x3 into x4 minus x3. Okay, so again, all the values known to us. Y3 just now we got x3. X3 is how much? Is 0.06. X4 is 0.08. So everything we have to put here, and then we'll get 1.07556. Okay, this one will come. And finally, we come to the end. Y5. Okay, y5. So it's y4 minus x4 divided by divided by divided by y4 plus x4 into x5 minus x4. So what is x5? It's 0.1. At what point we have to find the value of y, right? So we have come to the last part. So after putting all the values, you will get 0.979. Okay, this is the value. So that therefore, what is our y? At x equal to 0.1, our y is 1.09279. Okay, so you can round up it a little bit. If you want to round up it, then you can write 1.0928. Okay, or you can write like this. So after decimal, you will let us take at least 3-4 numbers. Otherwise, your result will vary a little bit from others. Okay, so this is very easy. So you try some other problems. Okay, take any problem in Taylor series. Also, if you check the earlier video, you will see that in Taylor series we did 2 problems. Those 2 problems also you can do it by an Euler's method. Okay, thank you very much for watching.